Alrighty, now that we have the basics of lists under our belt, let's go ahead and talk about some of the more complex operations we can conduct on them. So once again, we're going to start with an empty list. We're going to start with a list that has nothing inside it, and so is just one open brace followed by a closed brace. Under the hood, what that means is we have the luggage tag, my list, pointing at an empty list in a suitcase. So in the previous section, we saw that everything we did with the list assumed there were already elements in the list. If there was an element, we could pull it out from its index and then put another element back at that same index. But if there aren't any elements and therefore no indices to begin with, we're kind of stuck. So let's talk a little bit about how we can actually put elements inside a list in the first place. The formal term for putting elements inside a list is appending. And the way we do that is by calling the append function or method for a list. So in this case, if I were to execute the line of code mylist.append42, what that would do is that would insert 42 into this list over here. And specifically, although it's not clear from this graphic over here, we would insert that 42 at the very end of the list. What does that mean? Well, I think it's clearest if we do it again. So let's go ahead and call mylist.append100. Now you'll notice over here that after we executed this line of code, we inserted 100 into the list over here, but more importantly, that the 100 appeared at the very end of the list. Just like the word append means in real life, we're adding something to the very end of the list as opposed to somewhere in the middle. Okay, now that we've added that 100, let's go crazy. Let's add another number. Let's add 28. And again, you'll notice that 28 has been inserted into the very end of this list over here. So every time you append to the end of the list, and you can keep on going. I'm not going to go any further because you'd get really bored, but I could theoretically append to this list 500 times, and we just have a list with 500 elements. That's one of those things I told you about a little earlier on. It's really kind of exciting to be able to store so much in just one variable, and I think gives you a sense of how powerful a computer can be. You can store as many things in your list as your computer has space for. Literally millions or even sometimes billions if you wanted to. All right, now that we know how to append elements to a list, the converse and kind of clear follow-on from that is how we remove elements from a list. And it turns out there's a function or a method to do that as well, and it has kind of a fun name. That name is pop. So we can call the mylist.pop method, and what that's going to do is it's going to remove the element at the end of the list. So you'll notice over here that we had the element 28, and when we called .pop, we removed 28 from this list over here, and more importantly, the pop function returned that 28 back out so we could store it in a variable. What that means is that in one fell swoop, the pop function removes an element from a list and also tells us what the element was in case we needed to do something. All right, let's go wild. Let's just keep popping. So we're going to go ahead and once again call .pop, and you'll notice that the 100 was removed from the list and stored in the X variable over here. We can do it one more time and say, okay, now we've removed the very last element from the list and we've stored it in the X value. So we now have an empty list and a variable pointing to the most recently popped element from the list. Now, if you have any sense of Daredevil in you, I think the question that naturally comes up is, what happens if you pop from a list that doesn't have anything in it? I had that same question as well, so I tried it out, and as it turns out, you kind of just fall off the edge of the list, and you get a terrifying looking error message that says, index error, pop from empty list. That's basically Python's way of telling you, hey, you've asked me to remove something from this list, and I don't know how to do that because there's nothing there in the first place. Generally, when you see an error message like this, that's Python's way of telling you, hey, either you've done something wrong or I don't understand what you want me to do, so you need to be clearer. So in general, one thing to be careful of is that we're never popping from empty lists. And one of the ways we can be safe with that is by making sure that the number of elements in the list using the len function I talked about a little earlier on is greater than 0. All right, so now that we know how to append and pop, I think there's one other really important thing that you need to know that we can do with lists. and that is check whether particular elements are members in a list in the first place. So let's take a look at these two competing pieces of code. On the left over here, and in fact on the right, we're creating a list of numbers that has three elements: 42, 110. And down here, I have an if statement. That statement says if 42 in my list. Now, I don't even think you really need to know how to program to understand what this line of code is doing. But just to be absolutely explicitly clear, what it's saying is tell me whether the number 42 is an element in this list over here, which hopefully you can tell it is in fact an element in the list. And so this condition, 42 in my list, is true. And so we go ahead and print that the list has this element. If, by contrast, we checked whether -3 was on the list, which unsurprisingly it is not, we wouldn't execute this if statement, and instead we'd execute the else stanza, essentially saying that the element is not present over here. The really big takeaway is that a condition that looks like this, element in my list, evaluates the true if the element you're looking for is in the list and false otherwise. This is a condition that, like I've done over here, you can use in if statements, but you can also use them in while loops to check, for example, as long as a particular element is in a list, do something with it, and so on. All right, so now that we know about appending, removing from, or popping from a list and checking membership, there's one more kind of exciting development that we come to, and that is a new style of for loop. In the last section of this lesson, I talked a little bit about this for loop on the left over here, for I in range len numbers, which, just to quickly repeat myself, iterates over each of the indices of this list, 0, 1, 2, and 3, and then extracts the element at that list and then prints it out. So that hopefully is clear now, but it turns out that there's a simpler way we could write this for loop over here, and that's what we see on the right. For lm in numbers, print numbers. I gotta be honest with you, for loops like this are probably one of my favorite parts of Python, because you don't even really need to know Python to understand what this for loop is doing. It's so succinct and beautiful. We say, for each of the elements in these numbers, go ahead and print the element. So, something to be really clear about here. Both of these for loops are doing exactly the same thing. Both of them are going to print 1 first, and then 2, and then 3, and then 4. The high-level takeaway is that these two for loops iterate over each of the elements in the list in the exact same order. So I guess the question then arises, why do we need two kinds of for loop? That's so confusing. Well, I would argue that while they're both getting to the same answer, they're doing it with different working. On the left over here, we have one additional piece of complexity, and that is that we have access to this I variable over here, which tells us the indices in the list. The general recommendation I have is that if you need to know the positions of the elements in the list or their indices, I'd go ahead and use the for I in range loop. It's a little less pretty for sure, but it gives you access to more information. If you don't care where the elements are and you only care what they are, you can go ahead and just use the for loop on the right to just loop through all the elements without having to worry about the index. Okay, in general, the form of this loop looks a little bit like this. For element in collection, do something with the element. So what is this saying? It's saying that if we have any sort of variable that contains multiple values, for example, a data structure like a list or a dictionary, which we'll be talking about next week, we can iterate over the elements in those collections. So that's the for loop over here. I now think that we actually have all the tools we need to implement the function I told you about a little earlier on, add many numbers, which, to quickly rephrase, takes in some random number of numbers and returns the sum of all of those numbers. So this should work for just one number, it should work for two numbers, it should work for 20 numbers if we need to add 20 numbers together. So like I said, what I've got on the slide right now is not valid Python, but I think there is a key realization we can probably reach by this point, and that is that rather than having to specify a parameter for every number we want to add, we could instead perhaps leverage a list, which would allow us to pass in as many numbers as we wanted in one convenient parameter rather than having to create a new parameter for each of the numbers. So what I think this essentially could look like is a little something like this. Rather than having 50 parameters or 20 parameters or whatever, we have one parameter, numbers, a list, and that list contains 10 elements or 20 elements or 300 elements or however many numbers we want to add together. The question then becomes, if we have this function that's going to pass a list into itself and is going to calculate the sum of the numbers in that list, how do we do that? Well, for that, I actually want to jump into the Code in Place IDE, where you'll find this problem as a worked example for this lesson, and I'd like to talk about exactly how we could do this. So once again, we've got this function over here, add many numbers, that takes in a list of numbers and for which we need to find the sum of those list of numbers. We've also got some sample code that tests it over here. We've got a set of numbers, 1, 2, 3, 4, and 5. We call the add many numbers function, and then we print whatever it returns over here. So maybe take a second now to pause the video and think a little bit about exactly how you would solve this problem. I'm going to keep on chugging because when I prepared this lecture, I actually already solved this problem, but definitely take a second to make sure you understand this. So with that in mind, let's start by thinking about how we as humans would solve this problem. And let's imagine I gave you a handwritten list of a bunch of different numbers and asked you to add them all together. After telling me to use my calculator or my phone instead, if I told you I didn't have any of those things, you'd probably grumble and then settle down to adding the numbers together. And the way we'd probably do it is by going through each of the numbers that I had written down one by one and adding them together to one collective sum thing. So in order to go through each of the numbers, like we saw in our slides, we're probably going to need a for loop. That's a way to loop through or iterate through each of the numbers in a list. So let's go ahead and write the word for now. The question then becomes, do we need a range-based for loop or do we need just the elements in the loop? Because remember, the range-based for loop is used when we need the indices of the elements in the list. So in that particular case, let's think about this. If you were adding numbers together on my behalf, would you care whether you were adding the second and third numbers or the fourth and fifth numbers or the 19th and 20th numbers? You probably wouldn't. You don't need to know where in the list you are to be doing the sum. So I think it makes sense to, in this particular case, just use the simpler for loop that gets us each of the elements in the list. So let's go ahead and do that. I could say for lm in numbers, and that would be totally reasonable, but I'd like to give this variable a more descriptive name. So rather than saying lm in numbers, I'm actually going to say for number in numbers, which I think is a really nice pattern in Python. We take the singular form of the word and use it as our loop variable through the plural form of the word, which names the list. So now that that's done, we need to ask ourselves, what do we do with this variable? And again, let's think to ourselves how we would do this in our heads. If I was going through a long list of numbers and had to add all of them together, what I would probably have in my head is a separate number which calculates the total so far, and then every time I got to a new number, I would add that number to the total so far. Now, in programming terms, that total so far is what's referred to as an accumulator variable, which is not something you need to know even slightly, but I think is kind of a fun name for this. So I think the idea is oops, that should be a comment. We want to add this number to an accumulator variable. All right. So in order to have an accumulator variable, we probably want to create that variable first. So let's go ahead and do that. Let's say total so far is equal to 0. And then now that we have a total so far variable, we can go ahead and add number to it. So let's go ahead and do that. We can say total so far plus equals number. And then once we're done with all of our addition, we can go ahead and return total so far. And there we go, right? We've solved the problem. So let's go ahead and run our code. And as always, our code's going to work on the first try. except it didn't this time, which is sad, but let's think a little bit about why that is. Okay, so it looks like we've printed the number 5 rather than the number 15, which is what the sum of these numbers actually is in the first place. So let's go ahead and go back through our code a little bit. There's this really cool new feature on the IDE called replay, which you might wish to use in this particular case. And what it basically allows us to do is track through our variable values over time. So I'm going to go back to the start of the function over here and track through this. So we are going to start by looping through each of the numbers. So going forward 1, we'll notice the number is initially 1, the first element in this list. And so we add it to total so far, which is great. Total so far now has 1, which is the sum total of all of the variables we've seen so far. Now we move on to the next iteration of the while loop. That says number is now equal to 2. And then we execute the next line of code and whoops, total so far went back down to 0. That's probably not good. We don't want to delete the total so far every time we get to a new number. We want to remember how much we've added so far. So take a second to think about what the problem might be over here. I think to me, the issue is that every time this loop happens, every time we get to a new number, we reset our total so far, which is probably not the right move. We don't want to, every time we get to a new number, scratch out our total and start again. And so I think, just as we would in real life, we'd only want to set our total so far to 0 once before we've actually done any addition. So I think we want to put it up here before our while loop starts. And again, this is a very common pattern in programming, defining an accumulative variable before a loop begins. Alrighty, let's go ahead and try that again. I'm a little more cautious because I was overconfident last time, but this time I run it and it does in fact work. It looks like we got 15 printed over here, which is awesome. Alrighty, so now we've made a really huge step. We've now written a function that returns as many numbers, or the sum of as many numbers as we give it. We don't have to write an add 2 numbers and add 3 numbers and add 4 numbers section function or anything like that. So just to test that, let's go ahead and add a few more numbers. 6, 7, 8, and 9, and run the program again. That's fine. It's complaining because we're not printing 15 anymore, but we are printing 45, which is in fact the sum of the first 9 numbers. So we have in fact written a function that can accept as many values as we want and reason about them equally efficiently. So that's a really huge step. And now I want to take a break before we go into our next section, where I'm going to question exactly how it was that we passed a list as a parameter in this function over here. But go ahead and take a well-earned break, and then when you're ready, we can start the next section.